Good morning. We are going to talk about projectile motion. You probably learned about it in physical science a little bit. And I have some formulas up at the top here. So let's look at the formula on how to write the equation for projectile motion. That's -1/2 times gravity, gravity's down here, times x squared. -1/2 gravity x squared, plus the velocity times x, plus the initial height. So here's our formula to use. On the first problem, a rocket is launched from atop a 77-foot cliff. 77-foot cliff is the initial height, with an initial velocity of 160 feet per second. 160 right here times x. Now, if this is talking about feet, we need to use the gravity 32 for feet. -1/2 times 32 gives us -16 x squared plus 160x plus 77. That'll be our equation to write. H means height of t means in time is equal to -16 x squared or t squared plus 160x plus 77. Now I want you to pause this and put that equation into y1 and graph it. Your graph, which we only care about quadrant 1, your graph is going to look like this, where right here is that initial height 77, and right here is where it's hitting the ground. And it's going up, of course. It's following this path, going up until gravity starts pulling it back down. So that's 77 feet, and then it's launched up some certain height and comes back down and hits the ground. Right here is what we need to calculate for part B, graph and how long after it's launched will it hit the ground. Well, that's called the zero. You're going to calculate the zero in your calculate menu. You have the equation in y1, you looked at the graph, now calculate the zero. Do a left bound, a right bound, and calculate. That gives us an answer of t equals 10.5 seconds. It takes 10.5 seconds for it to hit the ground. That's kind of a long time, to tell you the truth. Now the second one, they give us the formula. They've given us the formula that d is in distance, like height, -16t squared minus 2t plus 683. That means it was launched from a height of 683 feet because of that number, and it was launched downward, that's why it's negative, at 2 feet per second. But the question is, how long after they throw it down is it at 480 feet? Again, I want you to take that equation and put it in y1 and graph it. Pause and get it graphed. That gives us the graph like this in quadrant 1, where we're looking here at that initial height, 683. Here is where it's hitting the ground. But our question this time is, when is it 480 feet? I want you to pause again and put into y2 480. Into y2 480. You have this in y1, that in y2. That gives us a line at 480 that's crossing right through that parabola. If we calculate now intersection, we'll find at what time it's at 480 feet. So I want you to calculate second trace intersection. When you calculate the intersection, you find an answer where t or x is equal to 3.5 seconds. Takes 3.5 seconds for it to get down to that height. On this third one, now we have to write the equation again, but it's just dropped. We have a cherry pie dropped from a tower 200 feet high. We're looking at 200 feet as the initial height, dropped, no velocity, and where is it after 2 seconds? We need to start with an equation though. So my equation will be h of t equals, because we're talking about feet, negative 16 x squared, no velocity because it's dropped, plus 200, the initial height. And the question is asking for at 2 seconds. So what I'm calculating is h of 2. And I throw in my calculator, negative 16 times 2 squared plus 200. That gives me an answer of 136. So multiple choice, C. Your assignment for both Monday and Tuesday is to finish the problems on the second page. You'll see the answer key here with the notes if you need to check back on it, and then for your homework to check that. Thank you.